Alright then guys, so today, do you ever entitle your notes, title polygons. Remember the fact you guys, poly stands for many. Gons, we'll talk about sides. We'll talk about polygons, many sides. You guys have heard polynomials? In algebra 1, polygons again, many. Nomials are terms. Remember you guys even talk later like about like terms, you know that? Polynomial just meant many terms. So polygons. The definition of polygon. Let me. Here, you still have your page, right? Yes, please. So polygon is a two-dimensional figure of straight line segments connected end to end. The segments may not intersect or cross at any point. Yes. Let me close them a little, but then if I close it all the way, then you guys cannot see your paper. So just a little. Are you looking like a blue thing in the center?
No,
like a big. You want to just move up for right now. Alright, so polygons, a two-dimensional figure of straight line segments connected end to end. And the segments may not intersect or cross at any point. So they cannot cross. So segments only, connected end to end, so it's not open, connected end to end, and then they cannot cross at any point. So here on my board, this one, I'm not gonna do it for the video, but at least that's a polygon. Right? They're connected from end to end. But if I was to go a little star, that's not a polygon because my segments are crossing. Also, sometimes with polygons, the number sides are, I'm going to give you guys a list from 3 sides to 12 sides. And then we're going to talk about what happens if they go more than 12. So some types of polygons, obviously with the number of sides, are, the first one, it's a triangle. That's the 3 sides. And quadrilateral is 4 sides. Right. Minimum size for a polygon are 3. Right? If we only have 2 sides, we cannot connect it. So that the minimum size of a polygon is 3. Triangle, many times it's three, angle, angles. But the cool thing is a triangle also has 3 sides. And there's many triangles. We talked about already, like about the acute triangles, the obtuse triangles, the right triangles. So there's many triangles. Quadrilateral, you guys have heard the word quad. The motorcycles that have 4 tires. Because quad means 4. Lateral means sides. So quadrilateral, 4 sides. So in the quadrilaterals we have what? Rectangles, squares, trapezoids. There's this thing that looks like a diamond, and we call that rhombus. There's this toy. It's a geometry figure, but people put a string to it and they fly it. People call it kites. It's a geometry figure, but it was made into a toy. All those are quadrilaterals. Alright, so 4 sides. For pentagon, we're going to call it for a 5-sided figure, and hexagon for 6 sides. So in fact, there's a building, a government building with 5 sides in Washington, D.C. It's a pentagon. Penta means 5. If you guys are into soccer, probably you guys have heard of Brazil, the Penta champs, because they have 5 championships. So Penta is 5. Hexagon, hexa, 6. I don't really see a connection in that one, but just remember it. Hexagon is 6 sides. Then we're going to get the heptagon is 7 and octagon is 8. Heptagon is 7 and octagon is 8. Septa comes like, for example, septa. If I want to change it to an S, septa, which comes from 7. And those of you from Latin, if you guys speak Spanish, you guys know septima. Septima is 7. So just see that when 8 in heptagon is 7. Octagon, you guys are familiar with that one, the UFC uses it because the ring has 8 sides. That's what I call it octagon. Couple that one, theirs is a regular octagon. The word regular means that all the sides are equal length, and the angles are also equal length. So like theirs is also a regular octagon. Now let's also move to nonagon for 9 sides and decagon for 10 sides. If you see nona, the beginning sounds like 9. Nonagon is 9 sides. Deca, you guys have heard decade, which is 10 years. So deca is for 10. So decagon is for 10 sides. For 11 sides, we're going to call it ondecagon. And dodecagon is going to be for 12. Ondecagon 11, dodecagon 12. If you guys speak Spanish, ande sounds like once, which is 11 in Spanish. Dode for dodecagon. Dode sounds like doce, which is 12. And then if you know your numbers in French, they're also similar to this. So those are the numbers from 3 to 12 sides. Alright, I'm going to come in the worksheet and also for the quiz tomorrow. I'm going to give you guys figures. You count how many sides. And I'm going to ask you name the polygon based on the size. So please learn this list. Learn it. Like you guys are going to count the sides, and based on the amount of sides, we're going to use the name. Like when I come and say it, name it based on the figures, that's what I mean. But then some polygons obviously can go more than 12. So if it goes more than 12, we're just going to come and say if a polygon with n sides, obviously my n is a big number, we're just going to call it n-gon. So a polygon with n sides is called n-gon. What I mean with that is like if it has 30 sides, I'm going to just call it 30-gon. If it has 50 sides, 50-gon. So I'm just going to, in fact, I'll even use a number. Don't have to write it in letters, just the number, 20-gon, 50-gon, 100-gon. So any number after 12, we're going to stop at, name-wise, we're going to stop at 12. Any number after that, we're just going to call it n-gon. And n is the amount of sides. So far, any questions? Okay. Alright. Bring it over. Okay. So on this one, please, like I said, learn the name. Today on the worksheet, obviously, you guys will practice. You guys count, oh, there's 7 sides. Oh, it's going to be heptagon. You guys can go on the list. But remember, it's more than quiz. Like I said, I'll give you guys some questions. And based on the sides, you guys will come up with the name. Now, our polygons, if they have a vertex, well, more than one vertex, vertex is the point where 2 consecutive sides of a polygon meet. Vertex is the point where 2 consecutive sides of a polygon meet. I know for an angle, I use the word vertex on an angle. And remember how it was the corner? I emphasize vertex, it's the corner of an angle. So the vertex is the corner of a polygon. If I have a rectangle, right? I could have any polygon. If I have a rectangle, I see a corner there. I see another corner, and another corner. So this thing has 4 vertices. But the plural vertex, we're going to call it vertices. So this thing has 4 vertices. Vertices, once again, the plural vertex. There's 4 vertices. The interesting part is the amount of sides and the amount of vertices is the same thing. So if I have a dodecagon, remember 12 sides, there's 12 vertices. So because later on, a few sessions later on, I'm going to ask you guys count how many angles there are. But it will be easier if you count the sides. It's easier to mark the count sides. It's the same amount of numbers. Then let me move on to our diagonal. Diagonal is a line segment that connects 2 vertices of a polygon and is not a side. So diagonal is a line segment that connects 2 vertices of a polygon and is not a side. Because our sides basically are connecting to vertices. those adjacent vertices means they're not next to each other. So a diagonal is a line segment that connects two vertices of a polygon and it's not a side. An example, let me come out with a hexagon. Right, hexagon because there's 6 sides. Let me come out with a hexagon, and there I see a vertex. I mean a diagonal. Right, I'm connecting two vertices, and then this segment is not a side. So that's what we call a diagonal. Obviously, there's more. I can connect that one, and I could go, straight line down, straight segment down to connect another diagonal. So my diagonals are basically connecting two vertices, but that is not a side. Most diagonals, or some diagonals, the diagonals are inside. So most polygons, the diagonals are inside, but sometimes they're outside, and we're going to talk about those in a minute. But those are basically it. Okay, then let's talk about what we call congruent polygons. Congruent polygons are two polygons that have all of their corresponding sides and angles equal. As a matter of fact, I'm going to even come up with an example. Congruent polygons are two polygons that have all of their corresponding sides and angles equal. As a matter of fact, on my figure at the side, I will just come and say that A, B, C, D, because I just gave a list of letters, I gave a list of points. I'm basically giving you guys a quadrilateral. So A, B, C, D, I'm saying it's going to be congruent to E, F, G, H. So A, B, C, D is congruent to E, F, G, H. That statement is very, very strong. What I mean with very, very strong, the first angle, angle A and angle E, I'm saying they are equal. And we can see they are marked the same, so we know they're equal. The second letter, B, with the second letter, B and F, I'm saying they're equal as well. And we notice B and F, they're marked the same way. C with G, and obviously D with H. So I talk about the angles, but if I look at the first two letters, A, B, I know that makes a segment. If I look at the first two letters from the other one, E, F, I'm saying AB, which is marked with a 1 slash, and EF are equal. And you guys can see that they're marked in the same way. That's a strong statement. False statement, I will come and say A, B, C, D is congruent to F, E, G, H. So if I move just two letters, it becomes a false statement. Because angle A and angle F, my figures are not the same. See, my angle A, my angle F, they're not the same. So A, B, C, D, congruent to F, E, G, H will be a false statement. Do you guys see that? See my point?
What about
H and A. So if I was to just come over and what if I switch my letters and I say H, G, F, E, for example? That's also a false statement because order matters. If I look at the first letter A, the first letter H, A and H are not marked the same.
But aren't all the sides the same?
Not necessarily, because I mark them differently. See how I marked AB with the 1 slash, but BC with 2 slashes? So because I mark them different, I'm saying they're not the same size.
So even if everything was exactly the same, but you marked the little lines on the side, it wouldn't be right.
If I mark them different, then I'm saying they're different sizes. If I mark them the same, like look at AB with EF, see how I mark those segments the same? Then I'm saying they are the same. So if I mark them the same way, I'm saying they are the same length. But if I mark them different, then I'm saying they're different lengths. Right? Even though we don't know the number, I'm just saying they're different. So that's why these A, B, C, D congruent to H, G, F, E will be false. Because angle A and angle H are not marked the same. Like order matters. Alright. But we'll practice a little more of that later, a few sections later. For today, from polygons, let me talk about convex and non-convex. As a matter of fact, our non-convex, we're going to use the word concave. There are two types of polygons, convex and non-convex polygons. Convex polygons are polygons where the diagonals of the polygon stay within the inside of the polygon, and not convex polygons will have diagonals that could cross over sides and the outside of the polygon. All right, we'll talk about it. I'll let you guys copy it, and then we'll discuss it in a minute. We don't have Dominic. Right, so convex, and I even have examples at the bottom. Convex polygons are polygons where the diagonals of the polygon stay within the inside of the polygon. So I came up with a pentagon, right, 5 sides, pentagon, and I drew all my diagonals. And if you notice, all my diagonals are inside, therefore is what we call convex. Last year, or the year before, I was talking to my students, and one of them said convex sounds like config. Right? Convex are those that are inside jail, they're inside something. If you notice, all my diagonals are inside the picture. So convex are all inside. Concave or non-convex, right? Concave is the word for non-convex. At least one diagonal goes outside. And we can see here at the far left, right? There is one diagonal that it goes outside. So that's what makes it not a convex. So that's why we call it concave. So convex, all the diagonals are inside. Concave, at least one of them went out. Now, once again, we're going to use the word concave for not convex. While you guys are finishing copying that, let me pass out the homework for today. And I gave you guys a lot of vocabulary today. I begin with the names of the figures. Make sure you guys learn those. And then also concave and convex. I gave you guys those as well. So I know we're using some new words in there. But let's practice it a little. Can I take this off? Okay, let's see if we go copy. So there are 2 types of polygons, convex and non-convex. Remember, those are not convex, we're going to call it concave. Convex are polygons where all the diagonals of the polygon stay within the inside of the polygon. So remember, I even used the relation convex, convex. They're all inside. Non-convex, which I say we're going to use the word concave, polygons will have the diagonals that could cross over sides and the outside of the polygon. And then said concave, basically at least one diagonal goes out. Not all the diagonals, because this figure that I have, it has a diagonal that is completely inside. So not all the diagonals go out. It takes only one to make this a concave. Right, there's a diagonal that is inside. Like I said, it only takes one to make it a concave. Can I take this off now? Yeah. It's kind of like yes and no, like yeah. Okay, maybe wait a little. So let's make yes. Here we get started. Yes. So the quiz for tomorrow, the angles which we reviewed yesterday, and polygons. Okay. All right. So now let me move on. Let's take a look at our homework. Now I have the first two questions there. The front side is asking, write the name of each polygon. And then the way we're going to name it, we're just going to count how many sides there are. So I'm going to come over and mark them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I'm going to say n equals 10 as in reference of their 10 sides. My little slashes, I'm not saying they're all marked the same way. I was just to be able to count. I was using those just to count. So I'm not marking them saying they're all the same length. So how do we call the polygon that has 10 sides? Decagon. So for the homework, help yourself with the notes, but try to remember them, because on the quiz tomorrow you will have to remember it. If you guys can review and write before you walk into class, that would be even better. Looking at question number 2, let me count the sides. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to say n equals 9 for 9 sides. How do we call something with 9 sides? No. Some people pronounce this nonagon. I call it nonagon. Tomato. Either way. I know people use potatoes, but I like tomatoes better. Tomato. I like that better. Alright, any questions on the front side? No? We're good with the names? Alright, let me turn the page. Yes.
Do you want me to wait after you?
If you can wait just a little, we're about to finish up. Alright, let's take a look at number 13. Say if each polygon is concave or convex. So, for convex, I know they're all the inside, so I tried to see if it is concave. What I mean with concave is at least one diagonal outside. Can you guys remember 13? Can you guys see a diagonal? Can you guys connect a diagonal that is outside of the picture? What I mean with diagonals, I'm thinking of this is a diagonal, this is a diagonal. If you notice, they're all on the inside. I cannot think of any of them that is out, so that's what we're going to call this convex. Now, for number 14, I see a diagonal, right? This is a diagonal. Because remember, diagonal are connect two vertices, and it's not a side. I see a diagonal that is outside, so we're going to call that concave. I was going to ask you if you have an answer. Yeah.
Oh, for non-convex, it's concave.
Yeah, so non-convex is concave. So remember, convex, all the diagonals are inside.
Okay.
Concave, one diagonal goes out. I could be more than one, but at least one goes out. So not bad. Right, any questions?